And software as a service, this is something that you know from Google Apps, that you know from SharePoint Online or CRM Online. This is when the vendor basically manages the complete application and you are only responsible for the business process and the data that it basically holds. Another way to look at that is basically the building blocks that we have there. So in the private cloud, you manage everything, from the hardware, the networking, the storage, up to everything that is above there. Infrastructure as a service, the networking, the storage, the hardware servers, and the virtualization environment, that is something that the vendor basically manages, and the operating system, be it Linux, be it a Windows operating system, whatever it is, that is something that you can install from a virtual machine. There's usually templates there, but to make it and keep it secure, to patch it, to update it, that is the responsibility of you. And everything that comes above that, be it the web server, be it the database, and so on, also your responsibility. So you still have a certain amount of IT management to do yourself. Platform as a service takes away the responsibility for the operating system, for the middleware, and for the runtime as well. So if you want to run Java, PHP, whatever application, Python, then the platform as a service will basically have everything under the application and the data itself managed for you. But it also means that you need to design your application to work in that way, to distribute over a certain amount of nodes and to scale up and down easily. There are considerations that you have to make. So for example, if you anticipate that you have millions of users, a single database is probably not the best way to deal with, right? So it's probably better to think about something like sharding, or in a traditional database world, it would be federation of databases. But you have to have a concept how you distribute the load evenly over multiple compute engines that deal with that. And software as a service, as I said, you basically have to deal with nothing of the infrastructure at all. It's always something that the vendor does for you. Now let's think a little bit about what could motivate you possibly to do something like this. So many think never change the running system, and to a certain degree that may be so. There is one of the large driver for cloud adoption that many mention is the economics. It is cheaper to run hardware or your system in the cloud. Well, it's not necessarily cheaper. If you have a server that you have under pretty good load all the time, 24 hours a day, it's working with, let's say, 50% load, then it may be cheaper that you run it on your existing environment. Don't touch it, not as the first system. Think about something that matches one of these patterns, something like on and off, the text pattern. Or maybe you think about a scenario where you have simulation engines that you run, hydrographic simulations, whatever you have in mind, and you do that once a year. And then not after that. Then in this case, it is not reasonable to basically hold off all the hardware and basically let it idle around for the rest of the year. This is a very good pattern for the cloud. Fast growing is a very good pattern for the cloud. If we think about the economics and the pattern that we have here, growing fast, unpredictable bursting. One application that I can show you as well is you may not want to be prepared for the worst case scenario. Blackout, if we want to take it less dramatically, but you can imagine a utility company that has to deal with that scenario. They have, during the time of the blackout, a lot of requests on their website, right? Mapping requests, other information requests. And then when everything works normal, nobody goes there. So nobody has a large interest to go on the utility website unless he's changing the provider. So this is where you deal with that unpredictable bursting, possibly millions of visitors there. Think about flood, think about wildfires, the event that you never want to be, that you need to prepare for, but you hope never comes. This is where you need to have enough load for this. Predictable bursting is that seasonal effect. One of the things that we first adopted was our licensing tool. It turned out that was one of the very old tools that we had there. And at the end of a quarter, for example, it's very busy. It broke down at one point. And this was one of the things that made perfect sense in the cloud. So at the end of the quarter, when we prepare the financial report, then all these things go very high up, and then after that, we dial it down again. Another scenario for economics in the cloud is also about not you spending, but you earning money, right? So you can reach out to a much larger audience. So think about this one. Selling an application or a solution through a packaged environment somewhere in one of these cloud scenarios. In this case, we have Esri here, selling ArcGIS server, not ArcGIS Online, the full-blown server on an Amazon EC2 machine, right? You rent it there, you can basically run it for as long as you need it, and then you basically return the license, you can dial it down again, and then you don't need it anymore. So this is one of the ways also to increase the reach that you have. This is more for a packaged solution or for a complete virtual machine with hardware and software infrastructure around it. But on the other side, you can also think about selling data. So there's a lot of providers. In this case, this is the Windows Azure Marketplace, where we have address cleansing tools, Melissa data, Locate. The United Nations provides a lot of environmental information in there. Esri, a lot of demographic information. So it's basically an additional channel to make people aware of the valuable information that you have and possibly sell it as well. And that without putting a strain on your own infrastructure that you have. Now, aside from economics, there are two more drivers. It's agility and it's focus. Agility basically means that when you have a change, when you have a brilliant idea, something that you want to add to your application, you don't need to wait necessarily for a release cycle, 3 or 4 or 6 months. Many of the companies, think about Google, think about Amazon themselves, think about us. We have weekly release cycles. And that could be something that you have as well. You can be very agile. You make the change, you test it, you press the button, and it's live immediately at thousands of servers if you desire so. And then on the other side, there's a lot of concern, of course. Does that mean that we have to sack people? Many don't think so. There was a big study that was made by the CFO magazine. CFO is the Chief Financial Officers. They have a magazine that addresses their audience together with Google, where they looked into the cloud, the benefits, the risks, and so on. And 75% of these CFOs thought that within the next 12 to 18 months, so by now it is only 12 months, they would embark somehow in the cloud, more or less, tipping their toes or full-blown. So that depended a little bit on their personal preferences and also on the size of the company and so on. And one of the benefits that they actually saw is that they can reassign and retrain and reassign the people that are currently doing nothing than maintaining the hardware, making sure that they are all patched, that you distribute the software, all these kind of things. That is a management effort that takes up a significant amount of the time of the IT department. They can refocus and concentrate on innovation. So Microsoft has an IT department of about 4,000 people. And when we embarked on that journey to the cloud and started to migrate all the applications that they were managing and all the software distribution and everything, device management, into the cloud, there was, of course, a lot of concern. We didn't lay off any of those. They were all retrained. They are now concentrating on more innovative application, faster applications, better applications, targeting all the devices and the consumerization of IT. We have colleagues as well that come in with an iPhone or an Android phone, and they make everything there possible too. So refocusing and leveraging the power of innovation is a big benefit for them. It's not just cost saving. Most of them think that they save an average of 20 to 30% of their IT spending by moving into the cloud. That's what the CFOs think, and that is what we can confirm from our own migration. On the other side, the agility and the focus on innovation are very important points for the CFOs. Now, when you embark into the cloud, you have to really think differently from a financial point, because often it comes along with a shift from capital expenditure to operational expenditure. So that is not nice for everybody. So in general, you have options, you can have pre-commitments and these kind of things, of course, as well. But imagine somebody like a developer, right? So he's having a dev and test bed that he needs to have up for months, for example, and then not anymore. So this is where you want to have immediate access and then basically spin it down afterwards. This is where the shift to an operational expenditure rather than having the capital expense for the hardware is often a rethinking process. The sales and marketing, by leveraging additional channels, by the amplification that we have there, is certainly something that you may want to consider as well. And also by leveraging the opportunity of making your data available, generating more awareness if that is your goal, or making more money by selling these data to additional audiences if that is your goal. And then engineering and operations, it is different, right? This Scrum, this very short release cycles is a very different approach to having a very fixed time frame where you have an operating system like Windows and you spend 5 years developing it, and then you have a fixed time where you have to basically throw it out of the window. Here we have something where you can do that with the press of a button, and you even have a new notion for that called DevOps. The developers are to a certain degree also those who are responsible for the operation of the application. There are certainly a lot of safeguards that you want to implement, but in general, there is a merger between engineering and operations into something that we call, or that the developers, the IT industry calls DevOps. There are some concerns, of course, as well. Some of them are valid, some of them are perceived. Is security really a concern? I think it depends on the data that you really, or the applications that you want to put into the cloud. It may not be appropriate for everything, right? It is safe enough for credit card information to have them in the cloud, right? Happens today. So they are in the cloud. You can access them through the cloud. There may be more vital information for critical infrastructures, for example, that may not be very appropriate to have in the cloud. It depends to a certain degree on the risk assessment that you have. But the access and the operations of such a data center, you can be assured, and the certifications, the compliance to certain standards confirm that the people who operate this, they are the best and they do that day in, day out. If you deal with, for example, a penetration test, every day twice or 3 times or 5 times, you are certainly more quick, more experienced, and you know what to do quicker and faster than if you do that once a month, right? It's just a habit of doing that. And this is what these people do for their living. They are very good at it. Compliance is something that we can basically confirm through certificates. And compatibility, well, you heard me talking about the openness, right? This is reality. You can basically develop with everything you want. JavaScript, yeah, works. Does work on Amazon, does work on Google, does work on the Microsoft platform, PHP, Python, all that works. You can take a virtual machine out of Amazon and launch it in VMware, or put it into Windows Azure if you choose so. There are limitations to that. Whenever you go to the border of one of these boxes, you are pushing the boundaries. And when you push the boundaries, you probably use certain vendor-specific implementations. And if you do that, then it is basically in your applications where you have to consider what are your options. For example, many of you are probably familiar with the Oracle Spatial Engine. And many of you that work with Oracle databases know PL/SQL, right? So if you work with PL/SQL, you cannot easily take the same code, the same data structure, and put it into a Postgres database or into SQL Server, right? So there is some sort of consideration that you have to make when you do that. But in principle, it is very possible to migrate a complete environment from Amazon to Windows Azure or vice versa. Now this is fortunately something that you can't see in very much detail, but I will talk about some of the building blocks that we have in the cloud. There is the global physical infrastructure. So if you have your application today here in the United States and you target maybe a market somewhere in Canada or maybe over in Europe, then you can be assured there is a data center that can serve customers there and that has lower latency and all these kinds of things. There is compute capabilities in that. So basically the data processing that we have. That can be things like virtual machines, but it can also be just CPU power that you use in your own applications. You can run all sorts of network connectivities to connect the public cloud with your private cloud. You can even build a virtual private network connection between the public cloud and your private cloud. So basically you have a network segment that runs in the cloud and connected to your own infrastructure, so that only you tunnel the information through it. It doesn't go through, it uses the public internet, but through a secure tunnel. So nobody can basically access this information. And then there's different storage capabilities from relational databases, including spatial capabilities, over NoSQL databases to normal blob storage. And then many of the services on top, like caching, like identity management, like media streaming and processing. There is things like complex event management, for example, that you can do on these clouds. And mobile device support, of course, as well. And I will go into a couple of these scenarios quickly. And I think I really have to be quickly. So let's go into some of those scenarios. I think if we look at the geospatial cloud in particular, the big ones, the known entities, they make pretty much daily news, right? We have Google there, their service that they have, API as a service, is also a part of cloud technology. They are one of the dominating entities in the news, maybe not in the last couple of months because of others. But they allowed us, for example, to reselect ancient Rome. Gone now, unfortunately. There was apparently a dispute between the organization that created it and Google. Now you can't access this information anymore. It's a big shame. I really love that one. But they continue to innovate. So from Street View, now they are going to provide us even these amazing images underwater. So this is incredible. So the amount of energy, innovation, and investment that goes into their mapping platform, this is really incredible. We are there as well. We have a platform that is very scalable, very well adopted in the market. We partner with Nokia. We actually don't own most of the data. Some of we do. But most of the data we rely on data suppliers like Pictometry, for example, for these beautiful oblique aerial images that we have. Nokia is our provider for the roadmaps in most parts of the world, although we still have some other providers as well. Nokia itself, that likes to call themselves the location company, is a rising star, certainly in web mapping now as well. They are a known entity, of course, for the offline data, if you want to use that in a database or navigation system, but they are definitely a rising star when it comes to web mapping. They are the power behind Yahoo. They partnered with us, and they will enable now, and they announced that recently, Amazon, for the Amazon API that is coming out, and they also announced recently an agreement with Oracle, so they are definitely on the march forward. Apple, they have spectacular 3D, spectacular 3D where they have it. But they made the same mistake that we did at Microsoft when we launched our Bing Maps platform in 2005. They didn't get the basics straight, right? So if you are searching for a location and it shows a city in the middle of the ocean, that is just not acceptable. So you can't compensate with that with the best 3D images that you have. I'm certain they will catch up, but for the time being, I'm sure many of you have seen the open letter from Tim Cook, where he basically suggested download Bing. He also suggested Nokia, okay. But he said he is very well aware that they are not in line with the high expectations that they had from themselves, about themselves. Open is of course coming as well, and OpenStreetMap gets better and better every day, right? So we all know that. It's constantly improving. It's free open data and open source software. Commercial offerings are available. You see here, for example, the implementation that Mapbox did based on cloud technology, right? So the Mapbox engines run in the Amazon cloud, and they basically power platforms like Foursquare. Esri is in the cloud. With many offerings that they have. The ArcGIS server on Amazon, ArcGIS Online runs on Windows Azure. So it basically leverages the Microsoft infrastructure. And through ArcGIS Online, you stream a lot of information and geoprocessing capabilities in SharePoint, in Esri Maps for Office, so that you have now the full powerful Esri Maps also in simple to use tools for the business decision maker, like Excel, for example. It's a wonderful development, a great step that they have made there, and I really love the simplicity of how to use it. And you see ArcGIS server on Amazon. This is one example. You can't read that, but it's from Government Technology. So 2 counties basically came together and they leveraged Esri on the Amazon cloud. By the way, in a way that they developed an application once and then they shared it between different departments. So it's a wonderful story that we have here as well. ArcGIS Online is one of the platforms that is very well adopted throughout the world. This is a public sector customer. Started actually as the European Environment Agency's Eye on Earth. Some of you may have heard about that. The European Environment Agency, and I had the pleasure to work with Jacqueline McGlade on the first iterations of this project. It has environmental information, as the name says, air quality, water quality, bathing water quality, noise watch they have as well. And they basically have official information and also have crowdsourced information, ratings from their users, what they think about the quality and the situation of the environment. Feedback loop is invited there. And this ran initially in the first iteration in their data center on SharePoint with Bing Maps there. Then they decided we want to invite other organizations, the United Nations and others as well. Now we have a lot of partners for the Eye on Earth around the world, and they put it then in the second iteration on Windows Azure. So in the cloud, scalable environment with multi-tenants so that you can basically also distribute and have separate administration rights for each part of that application. They did that very well, and then they basically said, but actually, we don't want to be bothered with any of this application management at all. So we go into this all-encompassing offering, the software as a service, if you want so, that Esri built with ArcGIS Online, leveraging a platform as a service. One of the sessions that we saw yesterday about open source, there was also the Open Trip Planner, multimodal routing. Great application, love it. Completely built on open source, and there is now an OTP deployer, the Open Trip Planner deployer, and that allows you to spin up your environment immediately in Amazon. You basically give it a GTFS feed, so that is basically an XML feed that describes your transport information, and then you can deploy it in the Amazon cloud, and you're there with your test bed within, let's say, hours. This was one of the applications that I built following the tsunami and the earthquake in Japan. So this leverages the cloud for the very same sudden peak requirement that we had there, and also shows how quickly you can actually implement something like this. So we have, when the disaster relief teams wanted to come to all these locations that were washed away by the tsunami, they had, of course, to fight with the drivability of the roads. Many bridges were gone, the roads were completely washed away, or there was landslides there. And then we basically, I was asked by some of my colleagues in Japan to help them set up an application that allows us to to have daily updates about the drivability of the zones and the roads in that areas. And we partnered there with Toyota and Honda. They have lots of cars for roadside assistance, so they were driving. And based on the trails where they were, we had pretty much, well, not a real time, but a daily update of the drivability of the roads, and we could also provide statistics how it improved day over day. In a similar scenario, less dramatic, but more frequently used, we have this also for the UK Environment Agency, also running in the cloud, flood warnings. So all the information that they have about imminent floods or floods in progress or warnings there run in the cloud on their website, integrated into their website, also developed by a very small partner in the United Kingdom, who is able to scale that up and down in case major floods happen. And they also decided that they want to go social and built it as a Facebook application. So you can basically connect also with your friends and then share the flood warnings that you and they have seen. VOGeo, so some of you may have heard about that. Now this is an amazing application that allows you to discover and customize a lot of maps. This is completely built around the Amazon cloud, and it leverages a lot of components that you see there. It runs on Linux, uses MySQL, a lot of open coding languages there, and the FME server. So even high-end system, we know that from ArcGIS already, but the FME server is also one of those that plays well in the cloud. This is a very small company, so they play touristic applications based on OpenStreetMap, and they decided that they want to run that in Windows Azure because they became very popular, had more and more customers, and then they needed to scale out, and they didn't want to buy new hardware. Natural regeneration cycle of the hardware coincided with that, so they basically decided we migrate the whole application. It took them not very long, only a few weeks, and we took the application and put it into Windows Azure as a multi-tenant application. So each touristic office has their own instance of this application where they can customize, look and feel, manage their own data, the types of data that they want to leverage there, and so on. Even the style of the data. And then coming back to the United States, 311 scenarios, we have heard about a couple of those. The City Sourced, for example, was one that we had a presentation this morning. They are also using the Windows Azure Cloud. They have similar situations where you capture graffiti, other incidents that you have, and then you basically do that from your mobile device, no matter what type of phone you have. You publish that into the cloud, and then you regenerate a workflow from there that basically starts then cleaning up the city or whatever the problem is, fixing the traffic lights. You can even have density maps that highlight then where you have hotspots and possibly do something proactively rather than going only reactively after each individual incident. But the opportunities are really endless. Chow Wai Young from the George Mason University in Washington has built a clearinghouse for geospatial data. So they basically have set up a crawler that looks for all sorts of spatial data, and you can explore them or even show them directly through that website. Runs also in the cloud and basically scales on demand. Microsoft Research have climate information that they provide through one of these environments and render also in real time. Now, I apologize, I'm always getting excited. I warned Claudia about that before the presentation. When I get started, I can hardly stop. But I'm at the end now, Claudia, and just want to summarize quickly. So I think the demand for information in the future is definitely increasing. We have seen some evidence of that over the past years, and I think all the research that I have shown you from various different companies indicate that it will explode in the future. And if you look back at Greg's statement that he anticipated that more than 2 billion more people will go into urban areas, you can also see that there is more demand for urban geospatial information systems. Now, with that, I'm really at the end. I apologize. I always get excited when I do this. And I hope it was informative. It lifted the mystery of the cloud a little bit for you.